All right, so now I'm asking you to calculate the probability of A plus the probability of A complement. Another way to say A complement is not A. So you could also say, what's the probability of A plus the probability of not A? Okay, so probability of A. What is the probability that you draw a red marble from the bag? Well, there's one red marble. There are 5 marbles total, so the probability of A is 1/5. Now what's the probability of not A? Well, there are 4 marbles that are not red out of 5 total marbles. So the probability of A plus the probability of A complement is 5/5, or in other words, 1. Next question. I ask, well, calculate the probability of A or not A. In other words, I'm asking if you rewrite this question as a sentence, I'm saying, what's the probability that either A happens or that A does not happen? So if I ask, hey, what's the probability that A happens or A does not happen? It doesn't even matter what A is. The probability of something happening or not happening is 1. So something is either guaranteed to either happen or not happen. It doesn't matter what it is. I could say, what's the probability that I find a purple unicorn today or not find a purple unicorn today? Probability of that is 1. Either I'm going to find a purple unicorn or I'm not. So probability of A or not A, it's always going to be 1. So this illustrates an important idea. The probability of an event happening plus the probability of the event not happening must add up to 1. Similarly, the probabilities of all the events in the sample space must add up to 1. So if you consider all possible things that could happen and add up their probabilities, it better add up to 1 because you've considered everything that's possible to happen. So now, often probabilities are difficult to calculate. However, we can often estimate probabilities.